MacBook Pro. It's a non-touch bar, 81708, and it's a no power. So first thing first, as always, before we introduce power to the machine, we first make sure to define what state the machine is in. To do so, we take out the back cover. I'm using a pendulum screwdriver. It's a P5. Okay, let's put that on side. Okay, let's see what we have here. The first thing we want to do is we want to disconnect the battery data cable. That's the battery management cable, and let's also. So usually, I would uh, just disconnecting the Apple data cable will be enough before we start making measurements on the board. But because this is not a factory, this is not a factory battery. So it's best to basically remove the main power line as well, which is by disconnecting by removing the screw. So that way we don't want to take any chances, because some of the Chinese battery, what happens is even when you disconnect the battery data cable or the battery management cable, the battery will still be active on the board. So just to be safe, we disconnect and we remove the screw for the main battery power line. Now after that is done, the next thing we want to do is we want to see what is our state, what state our board is in. So first and first, let's do a bit of a measurement in terms of, let's see if we have a short. First, we want to start by checking our PV bus line. Now, the board that we have, let's say it's going to be an 820-00840. It's the board number. Let's quickly open that up. Okay, this is that's the board. Flip the board to the other side. Now, this fuse here, that is going to be the fuse to measure for a short. So that's a fuse on our PV bus, and that is going to be this guy here. That is the fuse here. So our multimeter is in continuity mode, black root to ground, and also in continuity mode, it doesn't really matter which goes to ground and which not. So let's do this. Okay, we don't have a short there. Let's quickly check on our 5-volt line if we have a short on our 5-volt line. You can check there. PPDCIN. Let's see, do I have a short there? No, we don't have a short. Okay, let's see. Also 5-volt in S4. Let's see if we have a short on our 5-volt S4 line. We don't have a short, and then let's see if we have a short on. So these are just random, however, quick tests to see. And then PP3 V3 S5. Let's see if we have a short there on that inductor. We don't have a short. We don't have a short. That's good. Now it's safe for us to connect our charger. So let's connect our charger and see what's happening with this board. Charger is connected. We are supposed to have 13. So if we have, depending on what you have on our PPDCIN, that will determine what you will get on our PP bus. Let's just see if we have haptic feedback on the trackpad. Nothing. Okay. Now let's see what we have. So just so that you guys, just so you know, the charger is working. Just confirm that here. That's it. You guys can see it's a working charger. So now let us see what we have on our PP bus line. Switch back to voltage mode. That will give us an idea of what is happening on the board. What do we have? We have 0.333. So now that is very much indicative that we are having a 5-volt on our PPDCIN instead of a 20-volt. Now this machine is rated for it is rated for 20-volt and not 5-volt. It is not an iPad or a cell phone that works off of 5-volt. This the MacBook lines, they work off of 20-volt. So at 5-volt, the device will not work. So we are having 5 volt, most likely, which is why we have 0 point something volt on our PV bus line. So the next thing we want to do is we want to quickly disassemble the machine, take out the board, and find out exactly what is happening, what we are measuring on our PPDC in 5 volt and why, if it is 5 volt. But the fact that because we are measuring 0 point something volt on our PP bus, that is very indicative that our PPDC in it's it's less than 20 volt. And also because and another thing is we have also checked that we do not have a short on our PP bus, because if you have a short on your PP bus, that can also reduce the voltage that you get on that line. But we have already checked, we do not have a short on our PP bus. So the next thing we want to do is we want to go see what we have on our PPDC in, and that will give us an idea why we have 5 volt, why we have 0 point something volt on the PP bus line instead of 13 volt. Okay, one is out. Let's put the shell on side, flip the board to the other side. Let's try to dust the board. Okay, let's do a visual inspection now. Now these are the two controllers. I'm going to flip the board to the other side for you guys to see. These are the two CD3215, CD32 controllers. So these are the port controllers. You have U3100 and then U3200. Let's open up the schematic for you guys to have a better understanding of what that is. 840, 840, where are you? 78, okay. So we are looking at U3100, U3100. Okay, so it says here primary AC USB. Uh, let's plug this. So it says primary AC USB-C port controller. So now we are supposed to have 20 volt in our PPDC in, that we can easily, here it says 20 volt USB XAV bus. So we are supposed to get 20 volt on either of. So we are supposed to get 20 volt from U3100 and also 20 volt going into the machine. So let us see what we have, if it's 20 volt or 5 volt. So let's check from this port first. Let's see what we have. Okay, as you guys can see, we have 5 volt and not 20 volt. So that is why we are having 0 point something on our PP bus line. That's a 0 point something on our PP bus line. Okay, so the next thing we want to do now is we want to find out if we have a short around U3100 and U3200. That we can do by checking out the LDO outputs. So let's switch our multimeter back to voltage mode. Let's see if we have a short on and around any of the CD3215s. Okay, yes, we do have a short there. That is not supposed to be. I'm just going to show you guys. So we have a short on C pin 53. So let's just check that. We have a short there, and then on side, no, on this one, that's fine. That's fine. On the other side, okay, we have a short. Most likely, this one is faulty. So now, because the shot that we have, we can say it's only represented in C3208, pin 53, pin 12, and R3210. But most likely that short is going to be caused by, and then we also have that. We also have connect. We also have communication with U28 2890. But that short is most likely caused by U3200. which is one of the CD3215. So let's just remove that first and see if our short will still be present. Okay, so that is out. Now let's see if we still have a short on that line. And we no longer have a short. Now, so our problem was U3200. Now, the thing with CD3215s, the thing with USB-C controllers is they work in pairs. So if one is faulty, the other will not work at all. And then also depending on what type of fault the chip itself is having. So sometimes one can have a type of fault, but will not prevent the other one from working. But in this particular case, we have a short on one of the chip, and that prevented the second one from working. So what we need to do is we need to replace that, and then we should have a 20-volt back, and then this should be a working machine. So let's prepare. Let's get another CD3215. And then so for this CD3215, you can get from a 2016, 2017, and also 2018. Also, you can use CD3215s from, but 2019 and above, they use CD3217. So our replacement is going to be from a similar board or any board from 2018 and below. Let's try to get a donor board real quick. See if we have something here. This should be put aside. Well, these are CD3217. Not used. Finished. Okay, let's check the other side. See, nothing. Okay, it's fine. We can take from here. So let's hope. Let's see. They here are fine. Okay. And the CD3215, 17, they have orientation. So be very sure to orient the chip correctly. And then we can, on our board view, we see that the red sign, that is where it says pin 1. And then on the chip itself, you will find a small dot. Chip manufacturers usually will use a small dot to indicate pin 1. So because, I mean, we see how it's oriented, so it means it's going to be like this. Pin 1 is going to be like that. Hmm? So we'll have to orient the chip. So first and first, let us work on the parts of the chip. Okay, now we're now ready to install the chip. Make sure orientation is right. That's our pin one. And then also just another thing, another way you can tell it's so if you look at this, you see this you see how it is, and then inside the small cutout here that symbolizes pin one. And then you look at it's also a dot on top of it. That is where your pin one is located. So make sure you align accordingly. Still need a bit of a I need to flow in its place. Let's try to reduce the heat. Okay. Okay, so we give it a bit of time for it to cool off. And then we can check again. So while we're waiting for the board to cool off, let's do a bit of a further visual inspection in case there's anything else we may have to take care of. Not pertaining to our current issue, but as a preventive. Sometimes you may have a failing cap or a cap that's it's started to. So if you can easily identify and address it, that would really be good. Okay. So now let's check to see if we have a short. Let's test to be sure that what we replace is fine. That's not good. That's not good. Okay. Let's see. Why do we have that? That's low. Hmm. Okay, so another thing that it's gonna be of concern is U2800. Let's just check something again. There's inductor here to U2800 seem quite low. Um, that's not that's not supposed to be. It's not supposed to be that low. Let's just check again. Nah, okay. So this is what we should be getting on that line. I'll show you guys real quick. So we should be having something like this reading. Yeah, 0319 at least. But here we're having 0.0. Nah, that's a problem. Okay. Okay, let's see. Hmm, that's a problem. That's a problem. That's a problem. That's a problem. Okay, let's remove the inductor from the from. Let's try to see. So what we're trying to do is to disconnect let's remove the inductor first because a short on that line will also prevent you from getting a functional board. So let's see what you have now with the inductor out of the board. So the inductor itself, I mean, we're not removing the inductor to obviously, we're not saying the inductor itself is faulty, but because the inductor is like a wire, so whatever you have on pin one, you have on pin two. So if you have, because we have a short on this side, if the short is coming from U2800, now U2800, what would happen is this inductor here will serve as a wire to bring whatever is on pin 1 to pin 2. So whatever short you have in there, you have it on the other side as well. So let's see what we have now. If we still have a short, yes, we still have a short. So yeah, we still have a short, but then obviously the inductor, it's yeah. Okay. What do we? That's not good. That's not good. That's not good. Okay. Hmm. Okay. U2800 will have to go. Uh, so not only was our CD3215 damaged, U2800 was also damaged. Okay. So this is our U2800. You need to find a way to hold it's hold it. That's just a shield. The component itself is underneath. Okay. Okay. Mm. Okay, now that it's out, let's see if we still have a short on that line. Okay. No, and then our short is gone. So that was definitely a problem. Um, yeah, so first and first, let's see what we have on the board. Let's see if we have a working board first before we adjust. So basically, that is our Thunderbolt controller. So let's first see what we have on the board before we worry about that chip. Let's see. Okay, okay. 5 volt. Okay. Let's see on the other side. What do you have on PP bus? Okay, let's see the other port. Let's check this port again. Hmm. So two things. It may be that the CD3215 that we installed itself is faulty. Let's yeah, let's take it out. Try and get another one. Or we can try to replace it again. Is it this one or that one? That one. This is the one I just took out now. No, this is the one I just took out now. Yeah. Yes. Can try to replace it again. Okay. Let's try again. Otherwise, we may just have to replace it. It still doesn't work. And by the way, we do not need U2800 to be present in order for us to have 20 volt on the board. No, we don't need U2800. So whether U2800 is present on the board, that is not going to affect our 20 volt. However, if we have a short, just like what we were having before, that may prevent the board from functioning the way it should, which is why we had to remove U2800. So whatever was connected to this device that basically affected the CD3215 must also have affected the USB-C, the Thunderbolt controller chip. So let's say it's 2800. Let's quickly do this. U2800. Show you guys what it is. So yeah, that's U2800. So it says USB-C high speed one. So that's U2800. So pretty much a lot of things. Hmm. Okay, let's give it a bit of time to cool off. And let's see. First of all, we check to be sure we don't have a short. Okay, let's check what we have. Switch back to voltage mode. That's not good. Wait, we don't even have, like, we don't even have So we just may have to just get another. Uh, we don't even have PP3V42. Okay, we need. Wait, that's weird. Not PP3V42 either. Okay, so let's check again. Because now we have in 20 volt, but we didn't have PP3V42 on. Okay, so this is okay. So we have 20 volt now, yeah. Because I'll just show you guys that we have 20 volt on one of the port. We have 20 volt, and then the boat should be starting, but we need more work. So 12, yeah, that's it. That's about it. So the board should be starting as it is now, but we need to replace that. So when I was saying something about depending on the section of the CD3215 that has failed, that would determine if you get 20 volt or not. You see, even on you see this, it's this particular one we have 5 volt still, not 20 volt on one, and obviously we don't have PP3 before too. But then it's the section that the communication the communication between this and that that requires the 20 volt present, that is not affected, which is why you can see get 20 volt on one and then you don't have 20 volt on the other. So let's quickly, so I'm just going to show you guys that this is actually working now, but we practically, I mean, we have a working machine now, but then we still need more work done. Also, we need to replace the controller, which is a thunderbolt controller. That also needs to be replaced. Well, is that? Then even need to. Yeah, that's enough. Let's see that we have. Okay. I think there's a second port. The first port is the one. So we have trackpad feedback. Machine should be booting up any moment from now. Yes, that's it. As you guys can see, the machine is working. Obviously, I'm not gonna show the username. Okay, so yeah, as you guys can see, the machine is booted. However, that's not. We still need to do more work because one of the port is not working. So let's reinstall that CD3215, and if it doesn't work the way it should, we just have to replace it completely. So let's try to reinstall it again, take it out and put it back, see what happens. So, okay, so let's try to push this back a bit because this space. Okay, let's do this. Do you know this is like a manual reboarding process? Or you can just put it there. Yeah. Okay. That is good. Okay, that's good. So I'll put it back here. Hmm. I, I feel like I pressed just a little too hard. Just feel like that was a little too hard, just a little too hard. Um, okay. So whenever you are working on this section of the board, be aware of how much heat you have here, just not to affect the camera sensor. So you not the, so not, I'm talking about the image processor. Um, just, so so yeah, be aware. You don't wanna if you have too much heat here, it may affect the RAM here, and then which is for the image, and then you may have a system that will not board without a webcam. So just check to be sure we don't have a short. Even though I feel like I pressed too hard, just a little too hard. Okay, let's see now. Do we have at least we have a 3 volt first? Funny because now we just want to see if we have 3 volt first before we worry about then the other one. Okay, but now that we have 3 volts, do we now have? Okay, let's see. Do we have 20 volt? Yes, we have 20 volt. Okay, and then let's share the other port. Yes, 20 volt. Okay, so this is officially a done repair. So the next thing we're just gonna do just before we finalize this repair is we'll have to put back um, um, another Thunderbolt controller chip. So once that is done, we will basically finalize the repair, assemble the device, do the necessary testing, and then that will be it. Thank you guys. Yeah, that's gonna be all for this repair. It's time for prayers now. I need to leave. When I come back, I will just transfer just swap out the chip that is faulty also, and then that will be the end of it. But as you guys can see, it's already working machine. One of the board wasn't working because of the CD3215 that was not installed properly, so we had to redo it, and then yeah, then now we have 20 volts on both ports. And yeah, thank you. See you guys in the next one.